This is lesson 3 on simple harmonic motion. This is for year 13 physics, and this lesson is just looking at what does the shape of a graph for simple harmonic motion look like. So there are 3 possible graphs. The first one is a displacement against time graph. So if you're just thinking of simple harmonic motion, when timing starts at equilibrium displacement 0. When it reaches to one end, displacement's a maximum, and then the pendulum or the spring comes back to the equilibrium, and then it swings in the opposite direction to a maximum and then comes back. So a displacement time graph is essentially a sine curve. Now, a velocity time graph. Now, the speed's a maximum at equilibrium, and it's 0 at the end position. It's maximum again, but in the opposite direction when it goes to the other end, when it comes back through equilibrium, and then 0 at the end position, and then it swings with greatest velocity at equilibrium. So maximum at equilibrium, 0 at the end positions. And an acceleration time graph. Acceleration is always directed towards equilibrium, so it's in the opposite direction to displacement. So when it's at equilibrium, acceleration 0, it's a negative maximum when the displacement's positive at the positive end of its swing, and then comes back to 0 at equilibrium, and then the acceleration is a positive maximum when the displacement's negative, maximum displacement, and then comes back to 0. So this is actually a negative sine curve, whereas the velocity versus time is a cos curve, all for timing starting at equilibrium. This brings us to the term called phasors. What is a phasor? A phasor is a rotating radius vector. So this thing just goes around in circles, and traditionally we get it to go around in anti-clockwise direction. The tail is fixed, and it's the head that rotates anti-clockwise. Now, why are we talking about phasors? The reason is simple harmonic motion can be analyzed using phasors because displacement, velocity, and acceleration are all vectors. And so this is like for displacement starting at equilibrium. So this is when timing starts, and it goes around like this, and that's how you can trace your sine curve. And this is your velocity. Velocity is a maximum at equilibrium, so it starts from here and goes all the way around. Okay, so this was lesson 3.